All right, so we're going to do an old hard example. All right, so notice here we've got 4 terms. All right, and thankfully, I'm telling you up front, we're going to solve this using factor by grouping. All right, so these we're going to look for what these first 2 terms have in common and what these second 2 terms, the second pair of terms, have in common. So these, they have an x in common, looks like they have a 2 in common, and nothing else. So we're going to factor out a 2x. See here, 2x, the 4x is going to become a 2, and then you still have that sign of x hanging out. All right, I took a 2x away from this term, so now I have just a root 3 left over. All right, and then this one, you'll notice they don't have anything in common, but thankfully this part matches this part. So I'm actually just going to leave that second one the same. I'm just going to put it in parentheses, I guess, to make it look nice. So you're always wanting to try to make whatever this is, make it have that same something in common over here. And thankfully, it was the entire piece this time. So now I'm going to take the 2 halves, and I'm going to factor out that giant piece in parentheses because they have that giant piece in common. So a 2 sine of x minus root 3 is what I am factoring out from both halves now. Let's see here. The first half, I'm taking that 2 sine x minus root 3 away from it, so there's just a 2x left over. And whenever I take the 2 sine x minus root 3 away from this half, I'm just left over with a 1. Okay, and it was a plus sign, so I had the plus sign there. Right. Now we can go ahead and it's in factored form, so we can set each factor equal to 0 and solve. Let's go ahead and do the easy case first. 2x plus 1 equals 0. Move the 1 over. You get negative 1. And then divide by 2. You get negative 1/2. Okay. The second piece, we're going to set that equal to 0. So 2 sine of x minus root 3 is equal to 0. We're going to move the root 3 over. So you get 2 sine of x is equal to root 3. And then we're going to divide by 2. Divide by 2. All right, and this is what we want to solve for x here. It's positive, so since sine is positive, all right, those are like the y values. That means we're dealing with quadrants 1 and quadrants 2. So where does sine of x equal root 3 over 2? All right, sine of x, there we go, sine, is equal to root 3 over 2 right here at the 60-degree angle marker. So one of our answers, one of our x's, x is equal to 60 degrees or pi over 3. And then for our other one, if we have the 60-degree angle there, we want that same reference angle in quadrant 2, and that's going to be at the 120 degrees. So make sure you have that little special angles chart. It'll be real helpful with this in finding your second and possibly third answers. So 120, and that would be 2 pi over 3. So what I want to do is, since we have some time here, I want to go ahead and check our answers. So I'm going to take this negative 1/2 and plug it in for x here. So negative 1/2 stored x, right? And then I'm going to type this whole thing in. 4x sine of x minus 2x root 3 plus 2 sine of x minus root 3. And we did get 0. So that checks out. That's a good deal. It means we did good. And turns out it doesn't matter whether you're in radian or degree mode for this. All right. If I go back up here and reevaluate it again, it still works out. And the reason why is because of this little part right here. Just these linear terms by themselves, right? Turns out it doesn't matter what this sine of x part is. That's not what's driving the function to 0. It's, well, it's this piece right here. I mean, we wrote it in factored form. So this is the part that's making the entire function equal 0. So it doesn't matter, if you put in 1/2, whether it's in radian or degree mode here. Now, if you were checking the answers for these parts, it would matter. Like if you were doing 60 store to x or 120 store to x, you would have to make sure that you're in degree mode. And if you were doing these, you would have to make sure that you're in radian mode. All right. I guess just as an example here, let's go back to radian mode. I'm going to do pi over 3. So there's my pi. Store to x. And we'll just check it, make sure. Got the whole equation. And it does equal 0. Cool. That'll work.